Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying Trigonometry Lecture 5. So we'll be talking about transformation formulae from product to summation and summation to product both. Also we'll be talking about sine series and cos series, that is at the last. That is kind of optional, you might want to study, you might not want to study. That has not been asked earlier in PGDBA, but for the safer side we'll study that as well. So let us start a lecture with the first kind of transformation formula, that is product to summation. Although it looks like we are converting summation to product, but in actual questions it would be from product to summation. So basically we'll be using this kind of transformation in the actual questions. So let's start with the basic derivation. So it looks kind of obvious. Again, it's a brute force method. Sine of a plus b plus sine of a minus b. So basically we have to open both of them. Sine of a plus b is sine a cos b plus cos a sin b plus sine of a minus b is sin a cos b minus cos a sin b. So definitely these two terms are getting cancelled out. So what we are getting is 2 sin a cos b. That's a pretty simple one, right? Now let's say we are replacing a and b with theta 1 and theta 2. So we have got sine of theta 1 plus theta 2 plus sine of theta 1 minus theta 2. Now from now onwards, we'll remember these formulas in terms of this one. Why? Let me tell you why. So now let's look at this one first and then we'll go back to sine of theta 1 plus theta 2. In this case, we have sine of a plus b minus sine of a minus b. And result is more or less similar. Only thing is we have b over here and a over here. So what makes it different? We have minus sign over here. But what we can do, regardless that we can prove it with the brute force method, what we can do over here, we can write this as sine of a plus b plus sine of minus of a minus b, because we know that sine of minus theta is minus sine theta. So we did the reverse transformation over here. We did sine of minus a minus b. So that actually becomes sine of a plus b plus sine of b minus a, right? Now let's replace b with theta 1 and a with theta 2. Okay. Now b is theta 1 and a is theta 2. So what we are getting over here is sine of theta 1 plus theta 2 plus sine of theta 1 minus theta 2. Now we saw that this format is exactly same as this format, right? So basically this format is exactly same as this format. Only thing is we have replaced a with b over here because we had a minus sign over here. But in case if you want to remember these formulas in terms of theta 1 and theta 2, they both are exactly same, right? We have 2 sine a cos b and we have 2 sine b cos a. Just because of minus sign, we incorporated that minus sign inside the angle, and that again became this kind of formula, this format. So from now onwards we'll be remembering these two formulas with one single formula, that is sine of theta 1 plus theta 2 plus sine of theta 1 minus theta 2 equals to 2 sine theta 1 cos theta 2, right? Now let's move forward with cos of a plus b plus cos of a minus b equals to 2 cos a cos b. Again we'll be using brute force method, but we don't have any kind of shortcut or similarity in next two formulas, just like we had in terms of first two formulas, right? So we have cos a plus b, that is cos a cos b minus sin a sin b plus cos a cos b plus sin a sin b. This gets cancelled out. We have got 2 cos a cos b. Very simple, right? Simple brute force method, nothing else. And similarly over here, we have cos of a plus b minus cos of a minus b. Now the important thing over here is we have minus 2 sin a sin b. In every other case, we have got just 2 sin a cos b, 2 sin b cos a, 2 cos a cos b. But in this individual case, we have got minus 2 sin a sin b, and that's what makes it special. So we'll be remembering this with focus, that we have to apply minus 2 sin a sin b over here while doing the reverse transformation. Most of the time, we'll be doing the reverse transformation. Very rarely, we'll be using this kind of combination to convert these things into product with this kind of format, a plus b and a minus b. Majority of the time what we would be doing is we have been given sin a sin b, and then we have to convert this into cos of a plus b minus cos of a minus b, right? So we have to multiply minus 2 over there and divide by minus 2, and not just with 2. So we have to take extra care while remembering this particular formula. Again, the derivation is pretty simple. You just have to expand cos of a plus b, that is cos A cos B minus sin A sin B minus cos A cos B plus sin A sin B, right? So this term gets cancelled out. So we'll be getting minus 2 sin A sin B. Okay. So we have to take extra care while remembering this particular formula. That is minus 2 sin A sin B. Okay. Now let's move forward with this one question. Value of sine 21 cos 9 and minus cos 84 cos 6. So we can see that we have to use the reverse transformation over here, basically from product to summation. Otherwise, we won't be able to solve it because there is no way we can cancel out these terms in the product terms, right? We have to do some kind of transformation to summation or difference. In that case, only we will be able to cancel out these terms, right? So the first format is of 2 sine theta 1 cos theta 2. Remember that? We won't be remembering in terms of sine theta, sine A cos B, sine B cos A. We won't be doing that. We'll be doing simple 2 sine theta 1 cos theta 2. But we don't have an extra 2 over here. So what we'll be doing? We'll be multiplying 2 and divide by 2. So 2 comes over here. This becomes 1. 2 sine 21 cos 9 minus 2 cos 84 dot cos of 6. So 1 by 2, 2 sine theta 1 cos theta 2. That gives me sine of theta 1 plus theta 2, that is 30 degree, plus sine of theta 1 minus theta 2, that is 12 degree, basically 21 minus 9, minus 2 cos A cos B. That gives me cos of A plus B, that becomes cos 90, plus cos of A minus B, that is 78, right? Now this becomes 1 by 2. This is sine 12 minus cos 90 is 0, and minus we have cos 78, that is nothing but sine 12 only, with the help of complement angles. So this one gets cancelled out. Now we are getting 1 by 4 as the answer. Okay. Now let's do the reverse transformation. Basically, we'll be converting summation into product. In the previous set of formulas, what we did product to summation. Although we wrote in terms of summation to product, but we actually used product to summation. But over here, what we'll be doing, we'll be using summation to product. So derivation is more or less similar. So the earlier formula was sine of A plus B plus sine of A minus B equals to 2 sine A cos B. This was a formula, right? Now what we'll be doing, we'll be replacing A plus B with C. We won't be getting for questions in terms of A plus B and A minus B. They won't be making it simple, right? So they'll be giving in terms of sine C plus sine D, basically some formula, sine theta 1 plus sine theta 2, right? This kind of formula. They won't be giving in terms of sine of A plus B plus sine of A minus B. So let's convert that into this particular format into that format. So we have A plus B as C and A minus B equals to basically D. So we have replaced A plus B with C, A minus B with D. Now if we add both of them, we'll be getting A equals to C plus D by 2. And if we subtract both of these equations, we'll be getting B equals to C minus D by 2. And this would be applicable in every set of formula, right? So we'll be remembering that A is equals to C plus D by 2, B equals to C minus D by 2, right? We'll be starting with this kind of formula only. Now if we replace this over here, we'll be getting sine of C plus sine of D equals to 2 sine C plus D by 2 dot cos of C minus D by 2, right? Very simple. It came from the basic original formula, right? Now let's look at this one. This one is exactly similar to the previous one. And we saw that A plus B was C, A plus B was taken as C, A minus B was taken as D, and A comes out to be C plus D by 2, and B comes out to be C minus D by 2, right? And we have our basic formula over here, sine of A plus B minus sine of A minus B, that is equals to 2 sine B cos A, right? This was our basic setup. And now we have to replace these terms with this. So we have got sine of C minus sine D equals to 2 sine B, that is 2 sine of C minus D by 2 dot cos of A, that is C plus D by 2. Same formula, right? Now let's look at these formulas. cos of c plus cos d equals to 2 cos c plus d by 2 cos of c minus d by 2. Exactly same process, right? We don't have to do anything different over here. So the basic setup was cos of a plus b plus cos of a minus b equals to 2 cos a cos b. Same set of derivation, right? A plus b equals to c, a minus b, a minus b equals to d, and then using the summation difference, we'll be getting a equals to c plus d by 2 and b equals to c minus d by 2. Same thing, right? We just have to replace, and we'll be getting this particular formula, 2 cos of c plus d by 2 and cos of c minus d by 2. I'll be skipping this one because it's the same process. The most important one is the last one. So we have cos c minus cos d over here. So our basic setup was cos of a plus b minus cos of a minus b, and that was minus 2 sine a sine b. Remember that we had a minus sign over here, and this was the only case we had a minus sign, right? We didn't have any other case where we had a minus sign, and this was a special case. So in this case also, this one particular formula is special case. So again, we'll be doing the same thing, replacing a plus b with c, a minus b with d, a equals to c plus d by 2, and b equals to c minus d by 2. Now when we replace this one, we'll be getting minus 2 sine of c plus d by 2 dot sine of c minus d by 2. But the trick over here is we have a minus sign over here. Sometimes they'll give the formula 2 sine c plus d by 2 dot sine of d minus c by 2. That's the same thing because we can take a minus sign out from here and use it over here. I would prefer remembering this particular formula because the basic setup was minus 2 sine a sine b. Over there, we won't be remembering 2 sine a dot 2 sine of minus b. We won't be remembering that part of formula, that kind of formula, right? So similarly, we'll be remembering minus 2 sine of c plus d by 2 dot sine of c minus d by 2. Also makes sense because in every other formula, we'll be using c plus d by 2 and c minus d by 2. So that makes it more comfortable and less confusing, right? So that's why we'll be using minus 2 sine a sine 2 sine minus 2 sine c plus d by 2 dot sine of c plus c minus d by 2, right? So let's look at this particular question. The value of sec 11 dot sec 19 minus 2 cot 71. Okay. So this product is giving me a hint that we'll be using reverse transformation basically from product to summation, right? And but overall we have a chord setup over here, we have sec over here. So let's first convert all these things into sin and cos, right? That would be the best one before applying any kind of formula. Also, we don't have any kind of formula for sec theta 1 dot sec theta 2. We only have formulas for cos a cos b. So basically we'll be converting all these things into sin and cos, right? So let's move forward with that. We have sec 11 dot sec 19, that is 1 upon cos 11 dot cos 19 minus 2 cos of 71 dot sine of 71. Now we know that sine of 71 and cos 19 is same. So we'll be writing this as cos 19 only. Okay. Now let's take the LCM. That's the obvious thing to do over here. So we'll be getting 1 minus 2 cos of 71 dot cos of 11 divided by cos 11 dot cos 19. Okay. Now we can see minus 2 cos a cos b formula over here. So we'll do the reverse over here. Okay. So that gives me 1 minus, we have 2 cos a cos b. That comes from cos of a plus b plus cos of a minus b, right? So we will be getting cos of a plus b, that is cos of 82 plus cos of a minus b. That would give me cos 60 divided by cos 11 dot cos 19. Now cos 60 is 1 by 2, right? So this 1 by 2 is subtracted from this one. So we'll be getting 1 by 2 minus cos 82 divided by cos 11 dot cos 19. Now what I can do, I can write this 1 by 2 again as cos 60. So I can write this as cos 60. So this becomes cos c minus cos d, right? It also makes sense because we have a product in the denominator and we have a summation or difference in the numerator. So to cancel out terms, to make a final term, we have to do something with this one, right? So we have cos c minus cos d. That gives me minus 2 sine a, like minus 2 sine c plus d by 2 sine c minus d by 2, right? So we'll be getting minus 2 sine c plus d by 2. That gives me 60 plus 82. That is 142 by 2 dot sine of c minus d by 2. That gives me 60 minus 82. That is minus 22 divided by 2, that is minus 11, divided by cos of 11 dot cos of 19. Now this becomes 71, and this minus sign cancels out this one. So we'll be getting 2 sine 71 dot sine 11. Now sine 71 and cos 19 are same, so we can cancel these out. Now we are left with sine 11 divided by cos 11 with a 2 over here. So we'll be getting 2 tan 11 as the answer. So C is the correct answer. Now let's look at this particular question. Value of cos 2x plus cos 4x plus cos 6x minus 4 cos x cos 2x cos 3x. Now the obvious start should be to convert this product into summation or difference, because that would help us cancelling out terms. It's very difficult and tedious to convert this summation into this exact product, right? It would become very difficult to convert this summation into this product to cancel out terms, because eventually answer is in terms of integers, right? So basically everything is getting cancelled out, so it would become very difficult to convert this into this particular format. So the obvious start and easier start should be to convert this product into summation or difference. Now the basic idea should be to take this one and this one initially, because it's usually the case that we pick up pairs which add up to an even summation. So we have cos x over here and we have cos 3x over here. So x plus 3x 4x. We usually pick up the pair which gives us an even summation, right? So let's pick up 4 cos x and cos 3x, 2 cos x and cos 3x basically. So let's look at this entire term first. So we have minus 2 cos 2x, and then we have 2 cos x dot cos of 3x. We have 2 cos a cos b. That's a pretty simple one. We have minus 2 cos 2x. 2 cos a cos b is cos of a plus b plus cos of a minus b. So we have cos of a plus b, that is cos 4x, plus cos of a minus b, that is 2x. Remember that cos of a minus b is same as cos of b minus a, because cos of theta equals to cos of minus theta. So x minus 3x, that would fetch us minus 2x, but doesn't matter. We have cos over here. It becomes cos 2x only. So now we have got two terms over here. That is minus 2 cos x cos 4x. That would give me minus 2 cos 2x dot cos 4x and minus 2 cos 2x dot cos 2x. Now again we have 2 cos a cos b over here and again 2 cos a cos b over here. So we have minus as common, we have got 2 cos a cos b. That would give us cos of a plus b, that is cos 6x, and cos of a minus b, that is cos of 2x. In this case minus as common, we've got cos of a plus b, that is 4x, and we have got plus cos of 0, that is 1, right? Now eventually what we have got is minus 1 minus cos 2x plus cos 4x plus cos 6x. This is what we have got. And initially what we had is cos of 2x plus cos of 4x plus cos of 6x. So this term, this term, this term gets cancelled out with all these terms, and what we are left with is minus 1. So minus 1 is the correct answer. Now let's start with the last topic, that is trigonometric series, and this has not been asked in PGDB earlier and has a less chance of getting asked in future as well. But we are doing this as a safety net, right? We might get a surprise because PGDB is giving a lot of surprises recently. So we might get a surprise. So let's remember these formulas, and also the derivation part is really important because that would help us, to build up a thought process for further questions which are there in series, right? So the derivation part is really important. Now, the first obvious thought to convert this series into this one singular term is to create a different series, right? That is the only way to do that. And we can do that in multiple ways. So the first way, let's say we are multiplying cos of beta over here. We are multiplying and dividing by cos of beta. So the first term becomes sine of alpha dot cos of beta. Second term becomes sine of alpha plus beta dot cos of beta. Now this actually is the format of 2 sine a cos b, 2 sine theta 1 dot theta 2, remember? Right. Now this particular formula might give us different series or might not, because that would give me sine of theta 1 plus theta 2 plus sine of theta 1 minus theta 2. This would be the particular format this product would give, right? In cases where theta 1 is greater than theta 2, this would have a plus sign. In case we have theta 1 less than theta 2, we have a negative sign. So we're not really sure if we are going to get a different series in this particular case. So let's not proceed with that one, right? That would become tedious. Now let's look at the second approach. Let's multiply sine beta, like, because that would give me a formula of sine A sine B, and that would become cos of A plus B minus cos of A minus B, right? So that might create a different series, right? So let's multiply 1 upon minus 2 sine beta. So this would give me, the first term would be minus 2 sine alpha dot sine beta. Second term would be minus 2 sine of alpha plus beta dot sine of beta. The third term would be minus 2 sine of alpha plus 2 beta dot sine beta, right? Now this would become, that is minus 2 sine A sine B, right? So that would become cos of alpha plus beta minus cos of alpha minus beta. Now we also, this alpha minus beta difference is also irrelevant, right? Because we have cos over here. In case of sine, it might change the sign over here, but in case of cos, it's not going to change the sign, right? Now the second term would become cos of alpha plus 2 beta minus cos of alpha. Third term would be cos of alpha plus 3 beta, and this would become cos of alpha plus beta. We can see that terms are getting cancelled out, but quite in a distant manner. This would cancel out eventually, but we'll be left with two terms over here and we are left with two terms over here. So we're getting four terms in total, and that's a big possibility that we might not be able to convert these four terms into one singular format. We might be able to do that, but that process would become very difficult, right? So again, we'll be rejecting this particular idea that will be multiplying and dividing by minus 2 sine beta. So now let's try to multiply with minus sine beta by 2, right? So what we are doing is we are multiplying and dividing by minus 2 sine beta by 2. So the first term becomes minus 2 sine alpha dot sine beta by 2. Second term becomes minus 2 sine alpha plus beta dot sine beta by 2. Third term becomes minus 2 sine alpha plus 2 beta dot sine of beta by 2. Now this would become, this is of the format minus 2 sine A sine B. That would give me cos of A plus B, that is cos of alpha plus beta by 2 minus cos of alpha minus beta by 2, right? This term would become cos of alpha plus 3 beta by 2 minus cos of alpha plus beta by 2. Now we can see that the diagonal terms are getting cancelled out. This term becomes alpha plus 5 beta by 2 minus cos of alpha plus 3 beta by 2. Now if we extrapolate this for the last term, so we'll be getting minus 2 sine alpha plus n minus 1 beta dot sine of beta by 2. So we'll be writing as cos of A plus B and cos of A minus B. So this would become cos of alpha plus n beta minus beta by 2 minus cos of alpha plus n beta minus 3 beta by 2. Now we can see that these terms are getting cancelled out, diagonal terms, right? So in the end, we are left with just this term and this term, these two terms only. And there's a good possibility that we might be able to convert these two terms into one singular product, right? So let's do that. So we have minus 1 upon 2 sine beta by 2 over here, and multiplied with cos of alpha plus n beta minus beta by 2 minus cos of alpha minus beta by 2, right? So this would become minus 1 upon 2 sine of beta by 2, and this is cos c minus cos d, that is minus 2 sine of c plus d by 2 dot sine of c minus d by 2. So the first term would become minus 2 sine this plus this by 2. So we have 2 alpha plus n beta minus beta by 2, right? And dot sine of this minus this by 2. So alpha gets cancelled out, we have got n beta by 2, right? So this becomes, this minus minus gets cancelled out, we have this 2 gets cancelled out, this actually becomes sine of, this is alpha plus n minus 1 by 2 beta multiplied by sine of n beta by 2 divided by sine of beta by 2. So this is the formula which you have to remember for this kind of series. So the formula is sine of n beta by 2 divided by sine beta by 2 dot sine of alpha plus n minus 1 by 2 beta. Right? Now if you look at the cos formula, this is exactly the same. The only thing we have over here is we have cos. The series is definitely in terms of cos only. So the only difference over here is we have got cos over here, and the remaining terms are same. Sine of n beta by 2 upon sine of beta by 2 dot cos of alpha plus n minus 1 by 2 beta. The difference is just cos. So if you remember this one, the other one gets remembered easily, right? So this lecture was till here only, and this marks the end of trigonometric series for PGDBA. And we'll be doing certain additional problem solving sessions for trigonometry in Prep Master Portal. And after that, we'll be starting with set series over the YouTube, right? So let's meet in the next lecture of sets, and thanks for watching.